What's up, everybody? In this video, we're going to talk about the Anova, or analysis of variance. So what is it and what is it used for? When you are testing hypotheses, let's say you have something like HO equals, and you're comparing, let's say, one and another mean. Here, the difference is that you are adding another one or more. So essentially, the ANOVAs, the analysis of variance, is when you have more than two elements that you are comparing. Here you're trying to figure out if there are significant differences between clients. They go to stores in the morning, afternoon, at night, and let's say it's across 5 stores, so A, B, C, D, and E. So the way for you to solve this is essentially a math exercise. And the way for you to start solving these problems is first doing the marginal part. So essentially you're going to take all these rows and finding the average. So add all those numbers and divide those by 5. So for you to get the marginal. So you'll get 92.4. Here is the same thing. So it's 85 plus 87 plus all these numbers divided by 5. You'll get 81.6. Here in the bottom row is the same thing. You'll get 76.6. And then what you do is average these three elements, and you will have here an important element that we will be needing for the next table, and this is 83.53. Here we're going to do the same. So for all these three, we're going to average those out. You'll find it's 87.33. This next one is 86.67. This next one is 77. This is 93, and this one is 73.67. Before you go any further, you have to average all these out and see if the number is the same. If it's not the same, you're making a mistake. So you need to check your math, because if either you do like the average from these elements, you're going to get this number, and if you do the average from these numbers, you're going to get the same number. If you have the same number, you are correct. So you have all these elements, and now the next step is as follows. So we have 5 columns, and we have the average number. So what we are going to do is 5 times, then you're going to open brackets, and then you'll do is 92.4. So it's this number minus the average, what we have here, 83.53 squared. I'll explain to you in a bit what is it that we're doing. So 81.6, it's the same thing. So we're taking this number minus the average, again this number here, 83.53 squared. And lastly, you're going to do the last number, so this one, so 76.6 minus 83.53 squared. Just plug those numbers in a calculator and you'll get 652.13. And then we're going to do the same thing for the bottom row. So we have all these ones, and we're going to do the same operation. So it's 3, because we have 3 rows. So the first one we had 5 columns, now we have 3 rows, and we're going to do the same thing. So 87.33 minus the average squared plus, and we're going to do all the same thing for the remaining elements. 80.67 minus 83.53 squared plus 77 minus 83.53 squared plus 93 minus 83.53 squared plus, I'm gonna get this down here, 73.67. Remember, it's this one, it's the last one we're doing here, minus 83.53 squared. And this will give us the value of 761.73. this is what's called the sum of squares. Lastly, what we are doing here is what's called the total sum of squares. And this is equal to, we're going to take out each number minus this one squared all across all these 15 numbers. So I'll just do a couple of them so for you to see how it's done. So it's 102 minus 83.53 squared plus 92 minus 83.53 squared. We're going to do all the same thing until we reach this number. So plus 76 minus 83.53 squared. And this will give us the value of 1,877.73. So now that we have these values, I'm going to just clean out this table. This is what we have so far. So we have the sum of squares of the first element, which is equal to 652.13. We have the sum of squares of the second element, which is 761.73. And we have the total sum of squares, which is equal to 1,877.73. We saw that we had 5 stores. So what that means is, since we are doing an F test, 5 elements, it's 4 degrees of freedom for the stores. And for the other one, we had morning, afternoon, and night. So it's 3 minus 1, it's 2 degrees of freedom. So now we are in the condition to start filling in our Anova table. So here's how it's done. So we're going to write down source. And the first element is called factor A. And the second element, because it's a two-way Anova, it's called factor B. Then we have what's called the error. Then we have the total. Then here, what we have is the degrees of freedom. Here we have the sum of squares. Here we have the mean square. And here we have F. So now, since we have the degrees of freedom from both, we saw that the first one was 2. The second one is 4. Because here, remember that this was morning, afternoon, and night, so it's 3, minus 1 is 2. Here, factor B is the number of stores. We had 5 stores, so it's 4. 5 minus 1 is 4. To figure out the error, you just multiply these two, so it gives you 8. And the total, you sum all of them. So 2 plus 4 is 6, plus 8 is 14. So this part is done. The sum of squares, we're going to use the values that you calculated earlier. So the first one is 652.13. The second one is 761.73. And now we don't have this one, but we have the total sum of squares. And the number that we had was 1877.73. Now all we are doing here is subtracting these two elements from this one, and it will give us the value of 463.87. Now to calculate this one, you just divide this one with this one. So you get 326.07. The second one, you're going to divide this one with this one. Gives you 170.28. And lastly, you're going to get this one divided by this one. It will give you 57.98. Now, you don't do anything else here, but you're going to do something here because you need the values of F. And the way for you to find the values, you're going to get this number and divide it by this number. So this first one will give you 5.62, and the second one will give you, so we're going to divide this one with this one, I'm going to give you 3.28. So now we have our Anova table filled in, and usually they will ask you something in regards to testing at the specific significance level. So let's say they ask you if there's a significant difference between the factors from the column to the row at 5% significance level. So essentially what they're asking you, let's just write in here the F. They're asking you at the 5% significance level, it's 2 degrees of freedom, and then you take up the error. What's the value? You're going to check that out in the F squared table. Remember that they have different significance levels. If you want to check the one for 5, here that's what they're asking you, and you'll get the number 4.459. So essentially what this means is that the critical value is the number that you found here. So the critical value is 4.459, but the value that you have here is 5.62, so it's here. And because this value is greater than 4.459, essentially what you say is that you reject the null. For the other one, if they ask you to do the same, so it's, let's just write the graph here real quick. So it's F at 5%, and now it's 4 degrees of freedom and 8. So 4, 8. You're going to check the table, and you'll find that the value is 3.838. And essentially what you see here is as follows. So if this one is 328, it will go here because the critical value is this one is 3.838. So here you don't reject the null. And that's pretty much it for ANOVA tests. This is an example for a two-way ANOVA. If it was a one-way ANOVA, essentially what that means is you wouldn't have, let's say, this one. So you would be only having, let's say, factor A, just one. So it could be, let's say, like financials. You would be testing financials across several stores, or number of clients across several stores. So essentially it's like a bunch of means that you are testing against each other to see if there's a significant difference. And you'll get an F value. In this specific case, it's a two-way ANOVA, so you have 2. And they are going to ask you in regards to one specific type. So let's say this one would be revenue and this one would be profit, for instance. So they will be asking you something like, if there's a significant difference in regards to revenue across several stores.